Welcome to qnawire.
Alright, let's start with our expression that we need to integrate. dl is equal to alpha L dt. We want to keep our variables on their appropriate sides, so we divide each side by L. Keep the L's on one side, keep the T's on one side. So we get dl over dl is equal to alpha dt. Integrate both sides from L initial to L final. And then same thing for t, but I won't express that because we just call it delta t, because that's the value we're interested in. But we would get ln L final over L initial is equal to alpha dt. And let's make these the exponent of e for each side to cancel out the natural log. And we should be left with LF is equal to Li e to the alpha delta t. Note that Li is just 1 meter, and delta t is 100 degrees Celsius, so this becomes e to the 100 alpha. Now, if you're worried about that constant you find sometimes you integrate, if you add the constant in right here and then solve for it, well, delta t is 0, Li becomes, or LF is Li, so you should find the constant as 1 anyway. So our expression does make sense, it is correct. Okay, now let's find some errors. First, alpha equal to 2 times 10 to the negative 5. So on this left side, we can find the approximation, and this one we can find exact. So the approximation for this linear expansion coefficient is equal to LF is equal to Li 1 plus alpha delta t is equal to, well, Li is 1 meter, so just 1 plus 2 times 10 negative 5 times 100. You should find that LF is equal to 1.002 meters this way. If we do it exactly, we have our equation from before. LF is equal to e to the 100 alpha. Plug in alpha, and you should find that LF is equal to 1.002 plus something that's different from this one. Just hold it in your calculator to find the error approximation. Now, we also know that percent error is equal to approx minus exact over exact times 100. So in this case, it will be 1.002 minus 1.002, and then there's some more in there that goes pretty far down, over 1.002 ... times 100, which you should find is equal to 2.00 times 10 to the negative 4% error. Now for part C, our linear expansion coefficient is just equal to 0.02 inverse degrees Celsius. Didn't say that before, but I'll say that now. And so our approximation, I'm going to do that on the left side as well, is equal to 1 times 1 plus alpha, which is 0.02, times delta t, which is 100. And we should get 3 meters. And then for our exact, we would do LF is equal to, well, 1 times e to the 0.02 times 100, which is equal to 7.39 meters about. So again, we'll do our percent error calculation, which is just 3 minus 7.39 over 7.39 absolute value times 100, and that's equal to 59.4%. Now, part D asks us to redo a question we've already done, but I will tell you that some key difference you should keep in mind, just like how we solved it before, our final volume equation will become volume initial times e to the beta delta t, or volume initial times e to the 3 alpha delta t, using the same steps as before. So again, just watch my video on it, problem 15, and you should just walk through it pretty easily. But I'll tell you that the first part you'll get 102 milliliters, the second part should be about 2.01 liters, and the third part you should see that you're 0.969 centimeters below.